Okay, so for circle theorem, we have a total of 7 rules. So in this video, I'm going to show you the first 4 rules in circle theorem first. Okay, so I'm going to show you rule number 1. So what I would like everyone to do is you use your compass to draw a perfect circle, and then you try to draw like how I instruct to you, because I would like you to understand why is the rule written in such a way. Okay, so for rule number 1, first thing first, we are going to draw a chord. All right, a chord is a straight line that does not pass through the center. Okay, so for this example, I'm not gonna make the diagram looks messy. It's gonna be a simple chord. So I was just gonna draw the chord in this way over here. All right, simple, friendly way. And then what do I do with this chord is I will be constructing some triangles. Okay, and the triangle, the tip of the triangle, it must touch the circumference. So for example, I will draw a triangle that will look something like this. Okay, all right, and then with the same base, my chord is like my base now. With the same base, I'm going to construct another triangle. So I would like to touch this part of the circumference. Okay, now I will also like you to try to draw this out so you can understand what I'm trying to explain later. Okay, now you might be wondering, should I touch this specific part in the circumference? The answer is no. You can go anywhere you like in the circumference. So once you're done with that, I would like you to use your protractor. Alright, I would like to use your protractor to measure these two angles over here. And you can just quickly pause the video to do this with your diagram and find out what do you find. Okay? So assuming you have done so, you will notice that your angles over here and here, it's the same. All right, okay, you will notice over here it's the same. So I can write over here, this is x, this is x over here. Now based on our finding, we can write down the rule of this. Okay, now, what makes the angle the same? All right, remember how do we draw the angle? How do we start? We draw from the same chord. So, this angle is created by this segment over here. Okay, these two angles is created by these segments. Right, so we can write a rule over here. Angles in the same segment are equal. Okay, so that's the first rule over here. Angles in the same segment. Can you see this angle? It belongs to this segment. This angle belongs to this segment over here. So since they are from the same segment, we can say these two angles are equal. All right. Now, I would also like to introduce an interesting way for me to remember this rule. I would like to remember this segment over here. It's like a platform. It's like a mini stage. Okay, I like to remember this as like a mini stage over here. And over here, these two lines are basically a pair of legs standing on a platform. So you can use your creativity to imagine there is a person over here, dancing around. All right, it's like a stick man with two long legs standing on a platform, and he is dancing or she is dancing with another partner. So let me draw another stick man over here. Okay, so you can see these two dancers. All right, they are standing on the same mini stage over here, a mini platform over here. So we can know that the angles in between their legs are the same. All right, so this is just an interesting way for me to remember this property. Okay, so that's rule number 1. angles in the same segment, all right, angles that's created from the same segment are equal. Okay? Rule number two. Rule number two requires you to draw two radius from the center. So for this example, I will have my center over here, and I will draw my radius. One of the radius is here, and one of the radius is here. Now, it doesn't matter how your radius look like. It can be more or less. It doesn't matter. All right. So what do I want you to do? Okay, what do I want you to do with your radius is draw two chords over here. Okay. So what you can do over here is from this line, you can draw up, and it touches the circumference. And from here, you can do something like this. Now, does it have to necessarily touch the tip directly above the center? No. You can actually move this part to here or here, right? It does not matter. Alright? But of course, for example's sake, I will start with a friendly picture first so you can understand. So what do I want you to measure over here is this angle. Alright, I want you to measure this angle and this angle over here, and try to find out what is the relationship that you have discovered. So you might notice one thing over here. Alright, assuming you have already done measuring, you will notice that this angle, it's always the 2 times of this angle, right? Okay, you can check your measurement again. You will notice that this angle is always 2 times of this angle. So if we would like to write an expression to show that, we can show that if this is angle x, this will be always 2x over here. Okay? So the second rule over here, we can say angle, right, at the center. Alright, why is it the center? Because we know that that's the center of the circle. Alright, this angle is created from the center. Okay, is twice the angle at the circumference. Okay? So angle at the center, which is this one, it's always 2 times the angle at this circumference. It is touching the circumference, so this is the angle at this circumference. Alright? Now again, you can feel free to redraw a new circle and try to move this tip point to over here, and you will happen to find the same relationship. That's why we can come up with this rule over here. Okay? So that's the second rule. Now for the third rule, you are required to draw a diameter. So a diameter, you must draw a straight line through the center of the circle. So it will look something like this. Alright? And what do I need you to do is to draw a triangle by using the diameter as its base. And the tip of the triangle must be touching the circumference, okay? So an example, it will look something like this. Alright, you can touch anywhere in the circumference and you will get something like this. And what am I interested for you to find over here? It's this particular angle over here. Alright? Okay, again, you can pause the video, use your protractor and measure and see what do you find. Assuming you have already done so, you will notice that this angle over here is 90 degree. Alright, it's always 90 degree. You can feel free to redraw this. Try to move the tip of the triangle to the other part of the circumference. You will notice this will always be the case. Okay? So based on this, we can come up with another rule. Alright? So we can say over here, angle in semicircle, it's 90 degree. All right, because angle in semicircle, remember the first thing that we draw, it's a diameter. All right, so in other words, if we were to remove the other parts, all right, we actually get a semicircle, because to draw a semicircle, we have to divide the circle by half, and the only way to do so is by drawing a diameter. So this angle is created by this semicircle. All right, so angle in a semicircle, all right, it's 90 degree. Okay, so let me fix back up the circle first. Right. And the fourth rule over here, I would like to introduce a new rule for you. Okay, and this rule and this term is called cyclic quadrilateral. All right, this is called cyclic quadrilateral. Now you may pause the video and try to think about what the cyclic quadrilateral means. All right, now if you have guessed it is a quadrilateral shape inside the circle, you are correct. So a cyclic quadrilateral will look something like this. Okay, I will draw out for your as a reference, and then you can try to do it on your paper or notebook as well. So the important thing about cyclic quadrilateral, that all the four sides, it must touch the circumference of the circle. Okay, it must touch the circumference of the circle. All right. So that's my example of a cyclic quadrilateral. Okay. So what I would like you to try over here is to try to measure the angles, all right, which is opposite each other in cyclic quadrilateral. So for example, if you were to measure this angle over here, I would like you to try to find a relationship between this angle and its opposite angle. So its opposite angle is referring to this angle over here. And again, I would like you to try to use a protractor, measure these two angles and to find its relationship. You can also use this angle. You can also use this angle and find the relationship between to its opposite angle and see what do you find. Okay, you can pause the video, use your protractor and try this out. Now, assuming you have already done so, you will notice one thing. You will find out that these two angles add up to 180. Right? You will find out that these two angles, they will add up to 180. And these two angles, they will add up to another 180. Because what we are looking at right now is a quadrilateral. And for the total interior angle of a quadrilateral, it will be 360 degree. Okay? So based on this, I can write an expression for my angles over here. So if let's just say this is angle X, and since I know that both of these will add up to 180, so if I'm interested to know what is this angle, I can just take 180 and subtract it by X. That will give me the angle for this. In the same case, if let's just say this is angle Y, if I'm interested to find what is this angle, I just have to take 180 minus Y, and that will give me the angle. So based on this, I can write my rule over here. This is written as opposite angle of cyclic quadrilateral they add up to 180 degree, always, all the time. Okay, so these are the first four rules in circle theorem. So once you have familiarized with the rule, I will strongly advise you to practice so that you will know how to apply the rules in your exam question or in your worksheets. Thank you.
Stop.
Stop.